In this video, I'm going to focus on the mutable set operators and methods. And those are operators and methods that you can use on a variable that refers to a set object to modify the set that the variable refers to. So in this particular slide, we're looking at some of the mutable operations. First, we have the augmented assignments for the union operation, intersection operation, difference operation, and symmetric difference operation. And in the bullets below each of those, we have the corresponding method names that can perform the same operations. Now, the key difference, once again, between, in this case, the assignments and the methods is that the assignments have to have sets on both the left and the right sides of the operator. And in the case of the left side of the operator, it has to be something that I can modify. So it's typically going to be a variable that refers to an existing set object. And on the method case, or in the method cases, each of these methods not only can receive as an argument a set, but can receive any sequence of arguments and turn that into a set and then apply the operation. So that's some of the operations we're going to look at in this video. We'll also look at various methods for adding and removing elements in sets. So let's go switch over to a terminal window, and to get us started, let me go ahead and create a numbers variable that refers to a set object containing the unique values 1, 3, and 5. And let's demonstrate one of those augmented assignments. Now, I'm not going to demonstrate all of them because they work the same basic way as the mathematical set operations we just looked at a few moments ago, 2 videos ago, and therefore there's no need to show them all again. But let's just show that you can, in fact, modify an existing set. So here we're going to do a union assignment operation. We're going to add all of the unique values from this set into the existing set as long as they are not duplicates. And to confirm that, we can evaluate numbers and see that the duplicated 3, of course, does not appear twice, but all of the other unique values do indeed appear. Now, just as we can do that with the augmented assignment, we can also do that with the update method call in the case of a union operation. So let's do this. Let's use a range call, which we know produces a sequence of integers, 0 through 9 in this case because the argument is 10. And now what's going to happen is the update method will create a set out of the values from 0 through 9, all of which happen to be unique. And it will then take all of the unique items from that set, combine them with the numbers set, and remove any duplicates to produce the resulting set. So if we go ahead and say numbers here, you can see we now have a set containing the values from 0 through 9. So again, all of the different augmented assignments and corresponding methods will work similarly to this, but of course performing their individual operations. Now, we also have the ability to add items that are not already in a set using the add method. So for example, if I say numbers.add and I give it as an argument 17, which is clearly not in the set yet, if I evaluate numbers after doing that, we can see indeed 17 was added. Of course, if I say numbers.add and I give it a value like 3 that's already in there, and I spelt numbers wrong. So let's do that again, numbers.add, and give it a 3. And then I evaluate numbers again. You can see that the set has not changed from back up here in snippet 7. Now, sometimes you may want to remove an item from a set, and it turns out there's several different ways to do that. So let's say we would like to remove the value 3. So if I go ahead and say numbers.remove with 3 as an argument, now 3 is in the set at the moment, so this will work. If in fact the value was not in the set, I'd actually get a key error as a result of that. So you can try that on your own. But let's go and evaluate numbers, and now we can see that the value 3 is no longer in the set. So you have the remove method to remove an item, and if the item is not there, you'll get an exception called a key error. If you simply want to get rid of an item and you don't care whether it was there or not, you can actually use a method named discard instead of remove. Discard does exactly the same thing but does not cause an exception if the value is not in the set. Now, if you don't care which value you remove, you just want to remove a value, perhaps you're working your way through the set and you just want to grab one value at a time and do something with it, you can use the pop method for that purpose. And because sets are unordered, you should not rely on what value will come out next each time you call pop. In this case, the value 0 was returned, and if I now go and evaluate numbers, I can see that 0 is no longer in the set. And finally, if you ever needed to completely clear out a set, you of course could use the clear method, as we have on other of the built-in collections in Python. And if I evaluate numbers after that, I can see that I get the empty set representation. And again, because curly braces with nothing in them represent an empty dictionary for an empty set, they display that as the word set followed by an empty set of parentheses.